Welcome to Insight Hub, the video series dedicated to the world of data and brought to you by Miracle's Data Practice.
Hi, I'm Samanita Boodle, working as Research Associate in AI and ML in Miracle Software Systems. Today, our topic would be HawkEye enabling image recognition on mobile devices. Let's get started with it. Let's see what today's agenda is. Initially, we'll be learning what is ML, and then we will have a quick overview of HawkEye application, followed by a live demo. We'll get to know the architectural flow of HawkEye, and then the custom model using SSD MobileNet. Finally, we'll see the Android integration. Let's get through it. So, what is ML? We all know that artificial intelligence enables computers to think and get smarter. ML is a subset of AI. ML includes statistical techniques that enables machines to improve at tasks with experience. The major goal of ML is to build computer systems that can adapt and learn from the experience. Machine learning is a category of algorithms that allows software applications to become more accurate in predicting outcomes without being explicitly programmed. Simply put, ML allows the user to make the computer algorithm to feed an immense amount of data and have the computer analyze and make data driven recommendations and decisions based on only the input data. Machine learning algorithms are often categorized as supervised or unsupervised. Supervised algorithms are the ones that require to provide both input and desired output, in addition to furnishing feedback about the accuracy of the predictions during algorithm training. Unsupervised algorithms, on the other hand, do not need to be trained with desired outcome data. Instead, we will have to use an iterative approach called deep learning to review data and arrive at conclusions. Unsupervised learning algorithms are also known as neural networks, are used for more complex processing tasks than supervised learning, which includes image recognition, speech to text, and then natural language generation. ML recognizes patterns on its own from the provided dataset and makes predictions. Deep learning, on the other hand, is a multi-layered neural network which is also a subset of machine learning. Let's see the overview of HawkEye. HawkEye is an offline application for a user to get details of the object's facial features through the means of visual recognition. HawkEye application uses the mobile app camera, which can identify and detect the real-time objects. Here, we'll be using two things, object detection and facial recognition. For object detection, the application detects the basic objects which are found in the work area, for example, AC, CPU, keyboard, laptop, etc. And also, we can able to see the labels of them on the screen. And then the facial recognition. This enabled us to identify the gender of the person, whether the person belongs to male or female, and also five types of emotions of that person, such as anger, happy, calm, serious, and sad. So let's get started with the demo and see how each of them are being recognized. You can see we have the laptop being recognized, and here we have the pen stand, and here we have the cell phone, and then you can see we have the door being recognized, and then the bag, mouse, keyboard. Here we have the CPU. Now let's see the emotions. You can see we got woman surprise, and then man's head, man's head, woman thumb, and we'll see here the AC. Yeah, you can see AC is being recognized. Flow of HawkEye application. Initially, we need to collect all the images of the objects that we are training. Once the raw images are collected, we need to put them in training. Here we are using a pre-built SSD mobile net which is of TensorFlow framework. We need to give the images for training of the model. Once the model is properly trained, we will get the SSD mobile net custom model. This model is then used for the Android integration. For this, we are using Android Studio. Once the application is properly integrated and working, the mobile application for object detection is up and ready and can be used properly. This is the basic architectural flow. Let's see TensorFlow framework. As we all know, TensorFlow is an end-to-end open source platform for machine learning. It is a library of high-performance numerical computation. It is the most famous deep learning library which was of Google's product. Its a flexible architecture allows easy deployment of computation across a variety of platforms. TensorFlow architecture works in three parts: pre-processing the data, building the model, train and estimate the model. TensorFlow is the best library of all because it is built to be accessible to everyone. TensorFlow library incorporates different APIs to build at scale deep learning architectures like CNN or RNN. TensorFlow is based on graph computations. It allows the developer to visualize the construction of the neural network with TensorFlow. This tool is helpful to debug the program. Finally, TensorFlow is built to be deployed at scale. It can be run on both CPU and GPU. It comes with a strong support for machine learning and deep learning. The flexible numerical computation core is used across many other scientific domains. Custom model using SSD mobile net. For building a model, we need to follow a few steps. Initially, once the raw data is collected properly for all the objects which we have to train, we need to generate annotations. For generating annotations, initially we need to crop the object in an image. Once the object is cropped in an image, there is an XML file that will be generated for every image. That is, for every JPG image in the raw data set, we will have an XML file. So once all the JPG images and the corresponding XML files are generated, we need to give this data set for model training. Once the model is properly trained, we need to export the model. Once the model is properly trained, it will be of the form .pb file. This file will be used for getting predictions, which can be done on a test data set. If the predictions are good enough, then we can say that the model is good and can be used. Let's see Android integration. For integrating the model with Android, there are few steps that we need to follow again. Initially, we need to add .jar files and .so files as the libraries. And then we need to link C++ project with a Gradle. The CMake should be configured and the model path and the label path to the project should also be configured. Once all these simple steps are followed, our Android application is up and running and can be used for object detection and facial recognition. Thank you.
Thank you for watching a video on Insight Hub. The video series brought to you by Miracle's Data Practice. For more videos, please visit miraclesoft.com/insighthub.